My name is KADİR, and I'm a fourth grade on the software engineering department, and my number is 020040301009. And today I'm making a presentation about my latest project that I will also use on the final exam. And it is also for my midterm exam, but I added some features and functionalities on my latest project. I hope you will enjoy. And first of all, I would like to talk about one small thing. My system doesn't allow me to share my screen and the video camera at the same time, so I will be making my presentation without my camera, but my voice will be on. So I'm extremely sorry if I cause any inconvenience while I'm making the presentation. So let's start with the code explanation. Here you can see the first rows is including the libraries that I have used on my code and on my project. Here we can say various libraries are important to handle different functionalities such as deep learning, and we can see as deep learning libraries, the first is TensorFlow and the second one is Keras, and also image processing and plotting, evaluation metrics, as you can see as sklearn.metrics, and confusion metrics, classification report. That these are required on my projects, and when you see the output, you will also understand why they are required for my project. And also I added this function on my final exam, for my final exam, sorry, and it is for web application development, and we know this as Flask. And also we have a debugger right now in here, and if we continue with the second function, it's also same with my previous one. We can say and explaining with data pre-processing function, and this function is a placeholder for any data pre-processing steps such as normalization and augmentation. Here it simply returns the input data without modification. So it's the same one. And when we take a look on 21st, between 21st and 36th, you can see that I'm using the new feature, and we name it model architecture using FGG16. And you can think that why I'm using this function and why does it have to be added. And I can simply explain that with it should be pre-trained model. If we pre-train the model, we can use the e-parts more efficiently. So I used FGG16, and I got a lot of assistance from the internet, and I also investigated on the cases, why do people are using this functionality on their project, on their deep learning project, and I loved it. So I also considered that I can use in my project, and uses the FGG16 architecture pre-trained on ImageNet. It removes the top fully connected layers and adds new ones for the specific task. The base model layers are frozen to retain pre-trained weights. So we can explain like this. And here you can see the three rows. It's about the defined data directories, and I am directing to those files. And we are also seeing that the shape that I have declared on the top of the project, like the height, width, channels, and number of classes, and it's also same. So the image data generator, it's also important for us to see the project output. So we can say like this, define the data augmentation techniques for training data and rescaling for validation, and the test data, like you can see in here. And we also have to load and augment the data. So here we are talking about the loading and the augmenting the data in here with train generator, validation generator, and test generator. And you can see the usage of it. And we are continuing by epoches. Like the epoch is here you can understand that it is the itinerary, like how many tries does have to be used on the project. It's also explaining how many epochs do we need. So it's the process of us to like teach the algorithm what do they need to like function. So we are here, you can see right now like the model compile and the history. And let me see. All right, so as simply understanding, you can approach that the trained model, like the itself, fits a model to the training data and validates it's using the validation data, tracks the history of training. So we are recording the trainings, and after that we are also validating to the data that tracks the history of training. So here we are doing this, and after that we have to see the output that we have been getting from the algorithm. And the first one is test loss, and the second one is test accuracy. Our first and main aim is to get the loss like less, and the accuracy must be higher, and it we can say it has to be decreased by every step. I'm talking about the test loss. And the second one is test accuracy, and it has to be increased by every step of our epoch. So you can also see like this, and we are saving the model every epoch. And we are talking about the last rows of my project right here. And we can say this this step of the code as like predicts the labels for test data. Like, where is the predict? Yeah, that's a predict, and we are predicting the labels for test data and computes the confusion matrix and plots it's using Seaborn. But like before that, I can say that we are evaluating the model on the test data, and it prints the test loss and accuracy here. And after that we are predicting the labels and like computes the confusion matrix, as I just said. And like the classification report that we have to talk about as the last rows. And I'm just excited, sorry if I made some mistakes on explaining the things. And we are creating a Flask application to handle image predictions, allows users to upload images and get predictions from the model. So we are finishing our algorithm and like writing the code by using an application for Flask, so that we are uploading the images and get prediction from the models. It's not that certain, but we are getting some predictions. Here you can see the output of my model, and that will be like way more clearer than my explanations. It is coming. But I think I can show myself right now. Like we are seeing the epoches, like they are counting by itself. And here you can see like the accuracy will go increased, as I said, and the loss in the fourth try we are seeing it's it's not going well, but it will be. So let us see like the 7 and the 8, it's getting like a slightly decreased, so the accuracy is going high. Here is what we are like thinking of, and the loss is getting so many like decreasing on the numbers. Every epoch cannot be that we have expected to like write the code. So we are just counting and training the model first of all, and after that we can talk about the outputs, and if we are unsuccessful we can talk about what we did mistakenly. And we are also can see the tables of it and the test loss and the output. let let us like let me show you the output. And the output is like here we are, and the output is like the 5 and the 7 and the 4. Like we can see like it's our vehicle, and the plots are 5, 7, 4, and it's getting more clearer. And like we are saving the models and the training results. And also we have to talk about the validation accuracy and the validation loss. And like we are aiming validation accuracy as 1, which is the 100%. We are getting so many results on every epoch that cannot be the same with the latest one. Like the third cannot be the same with the fourth. Here we can see here. And like I will be also making some chains on the project, and I will develop my projects with maybe connecting with some APIs to see the visual actions. So yes, I think we can finish at that stage because it's already 13 minutes, and I don't want to just waste your time by seeing the the same e-ports, and not the same but the similar e-ports. So thank you for listening to me, and I hope you enjoyed the presentation and the code itself. And I really appreciate for your time, and I wish you have a great day and enjoy the rest of your day. Bye.